One of the more important features of the ESA is called a listener. A listener on the ESA can be simply defined as a SMTP daemon which is running on a physical ESA's interface in order to process incoming and also possibly outgoing email communication. And the main function of a listener is going to be to control basic settings associated with the SMTP connection. Like, for example, a number of recipient connections originated by a single sender, by a single host, or maybe a number of messages sent to individual recipients per hour. And in addition, it is something that will also control two, I would say, most important components of the ESA, known as host and recipient access tables. Okay, at a very high level, I can tell you that the host access table, this is what's dealing with the email senders. This is what you would use to control email senders. So SMTP servers connecting to your ESA. And the recipient access table, it deals with email destinations, like our users and mailboxes configured in our domain, or simply envelope recipients. Now, an important thing about listener is that ESA allows you to be deployed with one or possibly two or even more listeners, depending on the amount of interfaces you have. Many organizations work using just one listener, which is generally working pretty well, unless your device is expected to handle large volumes of traffic, which generally means more bandwidth, or maybe when you deployed additional firewall and possibly IPS systems that are supposed to inspect communication going to and from our ESA. Because what one listener means is that you have one socket, SMTP socket, bound to a single physical port, which is listening on a single TCP port. So for instance, if this is going to be my M1 and my ESA, and let's say that this M1 is going to be connected to a firewall, and this is my DMZ. Okay, so this is physical interface M1 that uses one listener, which is expecting connections to be coming on TCP port 25. And this applies to connections coming from your internal network, from the inside, so from your internal SMTP server. Plus, it is also expected to handle connections coming from the outside, from external SMTP servers. Okay, of course, one obvious thing here is that since you are using one interface for incoming connections from the outside, and you also use this single interface to relay internal connections, you will have to share the bandwidth of this port among all connections, inbound and outbound. Now, the second problem here is that your firewall is probably gonna have some issues or might have some issues when inspecting communication coming from the outside versus from the inside, since all those connections are destined to a single port, TCP port 25. You have one listener, and one listener means that the device is listening on just one TCP port. So in a design like that, you could potentially have a problem, like if your firewall does not allow you to build layer 7 inspection rules based on layer 3, layer 4 information. And the same thing is going to apply to your intrusion detection prevention system that you could potentially deploy on the DMZ. In some environments, it might be simply easier to follow the two listener setup where in most cases you would want to bind one listener to one physical interface of the appliance and then use another listener on the second interface. If we go back one step to the previous example, this is my M1 which goes to the DMZ. So this would be an example of a two-leg deployment. My D1, let's say, is here, and it goes to the inside of the firewall. And this is going to make my private listener, because private listener is meant to handle outgoing connections, which is messages coming from your SMTP server, like when they are destined to, well, someone internal or in many cases to external destinations, where M1 would be configured with a public listener, which is meant for incoming communication. So for communication coming from the outside, like when someone sends an email to your internal domain. So this simplifies the design. Well, it gives you more bandwidth, that's pretty obvious. But it also somehow simplifies the design and management of the appliance, because your firewall knows that anything that goes inbound to the DMZ is coming from the external networks. So your IDS IPS firewall will require a less complex configuration. It's essentially slightly easier to manage a design like that, and it also makes the whole ESA config easier to read and follow. But I'm not saying that one listener design is bad. At the end of the day, it will all depend on the design of the network and on your requirements. There is also a special type of a listener called black hole. This is something that you could enable if you plan to measure a rate of incoming messages and test speed of the delivery queue on the ESA. This one is only available for configuration via the CLI. So not something that you would use to handle data communication in a production network.